So let's say you're seated peacefully in the exam, minding your own business, and they decide to give you something like this one. They say to you in the diagram, FH is a diameter of the circle with center O, FC is a chord, and LCH is a secant. LF is a tangent to the circle at F. E is a point on CH such that CE is equal to HE. So the first question for you, which is for 5 marks, it says, prove that FC is parallel to OE. So before we can go to the question, I want us to identify the theorems that we see in this sketch. Well, we know that FH is the diameter, so the angle subtended by the diameter at the circumference of a circle is 90 degrees because it's an angle in a semicircle. Now, furthermore, we can see that in this triangle, we have the converse of theorem 1, the one that says the line from the center of a circle to the midpoint of a chord is perpendicular to the chord. Do you see that? So we know that E is the midpoint because CE is equal to HE or EH if you like. That's fine. We also see that this chord FC or this arc FC, it subtends angle O1 at the center of the circle. The very same chord and the very same arc is going to subtend angle H at the circumference of the circle. And we know that the angle subtended at the center is twice as much the angle subtended at the circumference. Awesome. Now, furthermore, we know that LF is a tangent. We also know that OF is the radius of a circle. And of course, we know that the radius is perpendicular to the tangent. So furthermore, we know that the angle between a tangent to the circle and a chord is equal to the angle in the alternate segment. So we say this angle is equal to that angle because of the tan chord theorem. So now we are done identifying all the theorems. So we can go to the first question and destroy it. So it's asking us to prove that FC is parallel to OE. So in order for us to prove that lines are parallel, we need to think of 3 things. We need to show that alternating angles are equal, or corresponding angles are equal, or co-interior angles are supplementary. In other words, they add up to 180 degrees. So by so saying, I mean, if we can show that this angle and that angle are equal, then we have shown that FC is parallel to OE. Alternatively, if we can show that this angle is equal to that angle, we have shown that the lines are parallel. Or if we can show that taking this angle and adding it to this angle, we get 180 degrees. So the easiest we can do is to show that corresponding and co-interior angles are equal. That's the easiest we can do in this case. So let's go ahead. Let's start by showing that the corresponding angles are equal. So look, we tell them that angle FCH, which is this angle, is equal to 90 degrees. That's because it's an angle in a semicircle. Awesome. Now we also tell them that angle E1 is equal to angle E2, and both of them are 90 degrees. Why? Because we have the line from the center to midpoint of a chord. Well, you can specify if you like. You can say of chord CH. So then we can conclude and say, well, therefore, angle FCH is equal to angle E2. So we have shown that this angle is equal to that angle. So the conclusion we can draw is, therefore, FC is parallel to OE. Why are these two lines parallel? Well, it's because the corresponding angles are equal. Or you can say the corresponding angles formed are equal. But of course, if you don't want to say it like this, you can still say these two things. And then you can say to us, if we take FCH and then we add it to angle E1, you show us what we get. You say it's 90 degrees plus another 90 degrees, which is 180 degrees. Then you can conclude and say, well, therefore, FC is parallel to OE. Why? It's because the core interior angles are supplementary. Do you see that? So you still do these two steps, but you don't want to prove corresponding angles. Instead, you want to prove co-interior angles. So this is how you proceed. You discard these two steps. So it's up to you. Do you want to prove alternating, or do you want to prove co-interior angles? Awesome. So we have our 5 marks in the bag. Our happiness is complete. Now let's proceed. Now this is what the next question is asking from us. For 3 marks, it says, prove that OFLE is a cyclic quadrilateral. So I'm just going to highlight the quadrilateral. They said OFLE, OFLE. So this is the quadrilateral we are interested in. We need to show that this is a cyclic quad. So the easiest thing we can do in this case, because it's 3 marks by the way, we can actually show that the exterior angle of a cyclic quad is equal to the interior opposite angle. Do you see that? So let's go ahead and show them that. So in order for us to do that, we just need to show that angle OFL is 90 degrees because we already know that E2 is 90 degrees. So we say, well, angle OFL is indeed 90 degrees. But what is the reason for that? It's because the radius is perpendicular to the tangent. Or you can say the tangent is perpendicular to the radius. And then you also tell us that E2 is 90 degrees. Well, this one was proven above. And then you show us that OFL is equal to E2. So therefore, OFLE is a cyclic quad. So why do you say it's a cyclic quad? Well, this is the converse of an exterior angle of a cyclic quad. So it's the converse of that theorem. If an exterior angle of a quadrilateral is equal to the interior opposite angle, then that quadrilateral is a cyclic quadrilateral. So it's a converse. Awesome. So we are done with this one. But you could have also shown that the sum of two opposite interior angles of a quadrilateral add up to 180 degrees. So when you wanted to show that, in fact, to prove that this is a cyclic quad by using the opposite angles, you would have done step number 1, but here you would have said E1 instead. So you'd say angle E1 is 90 degrees because it was proven above, right? And then you show us what happens when you take OFL and add it to angle E1. So you say, if I take 90 degrees, I add it to another 90, I get 180 degrees. You have shown us. So what is your conclusion from what you have shown us? You say this quadrilateral is a cyclic quad. Why? You have used the converse of opposite angles of a cyclic quad. Because the theorem says the opposite angles of a cyclic quadrilateral are supplementary. But the converse says if the sum of two opposite angles of a quadrilateral is 180 degrees, then that quadrilateral is a cyclic quadrilateral. Do you see how does the theorem and the converse work? Of course you do. So it's over and out with this one. Our happiness is complete. Now let's look at the last one. This is what it says. It says, if the size of angle F1 is equal to X, express angle O1 in terms of X. Of course, you have to give reasons for your statements. So if you want to be a good lawyer, you need to make sure that you master Euclid's geometry. Because for everything you say, you must provide a reason. Right. Now, how can we express O1 in terms of X? And this is for 4 marks. So this is the easiest we can say. We can say the angle between a tangent to a circle and a chord is equal to the angle in the alternate segment. After that, we can say the angle at the center is twice as much the angle at the circumference. Over and out. So we say angle F1 is equal to angle H, and both of them are equal to X, well, this is because of the tan chord theorem. And then you say angle O1 is twice as much angle H. So you can say it is equal to 2x. Well, that's because the angle at the center is twice the angle at the circumference. Yes. And then you are happy with this one. So this should be the end of this video. Thank you so much for watching. I really hope you have learned a lot.